Till again, I am asking the same question between 2 and 5. In between 2 and 5, how many real numbers are there? Including.
Including 2 and 5, there are 4, sir.
What are they?
2, 3, 4, 5.
2, 3, 4, 5. Yeah, first of all, let's go to the concept of what are integers. -1, -2, -1, 0, 1, 2,
1.
so on. These are all called integers.
Yes, sir.
Integers, no fractions are there. No fractions are listed in integers. Integers means only numbers.
There are no fractions. Yes.
See, 3.1 is not in the list of integers.
Yes, sir.
5.6 is not in the list of integers. -1.2 is not in the list of integers. Okay.
Yes.
Now, after integers, these are rational numbers. What are rational numbers? A number which can be expressed in the form of p by q is called a rational number.
Yes.
For example, 1 by 2, 1 over 2, 3 over 4. To understand what is important, it is very important to recall the number system.
Yes.
And 7 is also a rational number. You know why?
No, sir.
7 is also a rational number. Because 7 can be expressed in the form of p by q. That means 7 means 7 over 1.
1 over 7.
No. 7 means 7 is equal to 7 over 1.
Yes, sir.
That's why 7 is also a rational number. So every integer is also a rational number. In addition to integer numbers, there are fractions also there in rational numbers.
Yes.
The definition of rational number is, the definition of rational number is a number which can be expressed in the form of p by q, where p and q are integers and q not equal to 0.
Yes.
Do you remember the fact denominator should not be 0?
Yes, sir.
Yeah. So every integer is a rational number, right?
Yes.
Every integer is a rational number. You know what is opposite to rational number? Opposite, antonym of rational number?
Irrational numbers?
Yeah, irrational number. It is irrational number. Irrational number. What are irrational numbers? A number which cannot be expressed in the form of p by q. Do you know there are some numbers which cannot be expressed in the form of p by q? Can you give an example?
√2, sir.
√2, very good. How could you know √2 is a rational number?
I don't know, sir. I mean, how do I tell you? I mean, I don't know how to.
Yeah. See, what's the value of √2? Don't you may say what's the value of √2? You may tell 1.414. Okay. Yeah. So let's work. Let's keep that point. Anyway, what's the value of √16?
4, sir.
4. Very good. Because 4 square is equal to 16.
Yes.
If you don't know the value of √16, what should we do? We don't know the value of √16. What should we do? Let us try. Let's try to find the value of root 16 in trial and error method. Let us take 1. Let us check whether 1 is a root 16 or not. To check whether 1 is a root 16 or not, we will find we do find the value of 1 square.
Yes, sir.
Is it less than 16 or greater than 16? This value
Less than 16.
So root 16 must might be more than 1.
Yes.
Go for 2. 4.
4.
Still it is less than 16.
Yes.
So it might be greater than 2 also.
Yes.
3 square.
9.
9. Still it is less than 16.
Yes.
So root 16 is somewhat greater than 3.
Yes, sir.
At that stage, we find 4 square.
16.
So it is 16.
Yes.
The same way, let's try to find the value of root 2. Let us try 1. 1 square.
1.
1. It is less than 2.
Yes.
So root 2 is less than 1.
Yes.
Let us try for 2 square.
4.
It is more than 2.
Yes, sir.
So root 2 is less than 4 and greater than 1.
Yes, sir.
Let's take 1.5. 2.25.
It's less than that.
0.25. It is more than 2.
Yes, sir.
So its value must be less than 1.5.
Yes, sir.
Let's take 1.4. 1.4 whole square 1.96. Is it equal to 2 or less than 2?
Less than 2.
Less than 2. So the value of root 2 must be 1.4, more than 1.4. Let's
Yes.
take 1.41. What's the value of 1.41 whole square?
Whole square. See,
it is 1.90, sorry, 1.8, 16, 17, 17, 18, 1. Yeah, 1.981. Is it equal to or less than 2?
Less than 2.
So the value of root 2 is something like 1.41. If we keep trying the value of root 2, it goes many hundreds of digits, thousands of digits, crores of digits. Even if I find the crores of digits, it can't stop there, because something square cannot be equal to 2. There is no number whose square is 2.
Yes.
There is a number whose square is 16.
Yes, sir.
There is no number whose square is 2.
Yes.
But if we try to find the square value of root 2, we get the value like this: 1.41 something something something, 1.414 something something. If we write crores of digits, it may not end up. That means, for example, if you find numbers 1.414 something 2, 3, 4 something like this, even if we find the value of this square, it can't be equal to 2. It may be nearly 2, approximately 2, something like 1.96, 1.981, something like this. We may get 1.99999, so on, but not equal to 2.
Yes.
That's why the value of root 2 cannot be written, cannot be expressed. If you write its decimal fraction, it can never end. It never ends. It will never ends. So, add one more thing. Of course, 1 by 3. If we write 1 by 3, it is 0.333333. It may not. It is also not ending, not terminating, but it's recurring. It is a recurring fraction. The value repeated 333 like that. If we take a fraction 1 by 4, it is 0.25. It terminates. It is terminated. It is recurring. But this fraction is not terminated, not recurring. Neither terminated, not recurring. That's why this can be, suppose if its value is 1.4, it can be expressed as in the P by Q form as 14 by 10.
But
1.4 can be expressed in the form of P by Q as 14 by 10.
yes.
If it is 1.41, it can be expressed as the P by Q form as 141 by 100. Even if it has 1000 digits after point, it also can be expressed in the form of P by Q. But it is neither recurring nor terminating its value. That's why it can't be expressed in the form of P by Q. Even after crores of digits, it is not recurring nor terminating. That's why the value of P by Q cannot be expressed in the form of P by Q. Sorry, the value of root 2 cannot be expressed in the form of P by Q. Agree?
Yes. Yes.
You might think that, oh, root 2 means root 2 by 1. Is it correct way to express the root 2 in the form of P by Q? No. The condition is PQ must be integers.
Yes.
Okay. So finally, the conclusion of this discussion is the value of root 2 cannot be expressed in the form of P by Q. Root 2 cannot be expressed in the form of P by Q. That's why root 2 is irrational number. Can you give such examples?
So anything with root except for square.
Root 3.
Root 3
Root 3 is also irrational number.
Root 5.
But not root 4.
Yes, sir.
But not root 4. Root 5 is irrational number. Very good. Root 5 is irrational number. What about root 9?
No, sir.
Root 9 is?
It's a rational number because 3 is
Yeah, right. Very good. It has 3 square is 9. Okay. So now the combination of rational and irrational.
complex.
No. Complex number is different concept. We know.
Has I, yes, sir.
Yeah. That is called real. Rational and irrational is equal to real numbers. Real numbers. Okay. Give an example for real numbers. Can you give example for real numbers?
Thanks.
2 is a real number. 3 is a real
5.
number.
Yes. Oh,
2 is
yes.
a real number. 1.2 is a real number. 1.0 or not 2 is a real number. 3.4 is a real number. 3.01 is a real number. 3.000000001 is a real number. 4.7 is a real number. Root 3 is a real number. Root 7 is a real number. These are all real numbers. Agree?
Yes, sir.
Now, the point is, now tell me, how many real numbers between 2 and 5?
4, sir. No.
I'm asking about real numbers. How many real numbers are there between 2 and 5?
Real numbers.
Yeah, 2 is a real number. You told, including 2 and 5, you told 2, 3, 4, 5.
Or 5. But then there's like
2.1 is a real number. 2.01 is a real number. 2.001 is a real number. 2.000000001 is also real number. In this way, how many real numbers are there between 2 and 5?
Infinite, sir.
Infinite real numbers are there between 2 and 5. Not 5, not 10, not 1000, not 100. We can write, if we are asked to write 1 crore numbers between 2 and 5, we can write 1 crore numbers. If we are asked to write 10 crore numbers between 2 and 5, we can write 10 crore numbers. We can write as many numbers as required between 2 and 5. For example, say two numbers which are very closer numbers.
Oh, 2 and 3, sir.
2 and 3. Please tell how many real numbers are there between 2 and 3?
Infinite, sir.
Infinite numbers are there between 2 and 3. Infinite numbers are there. tell so near, very near numbers. For example, if we take 2 and
So
2,
1.2.
2 and 2.1.
Yes.
How many numbers are there between 2 and 2.1?
Infinite, sir.
Infinite. How many numbers are there between 1.7 and 1.8?
So infinite, sir.
Infinite. Because one in between 1.7 and 1.8, 1.71 is there, 1.72 is there, so on 1.79 is there. After 1.79, it will be 1.8, right? Even between 1.71 and 1.72, we can write 1.7000, not 1, so on. So in between any two real numbers, however near they are, there lies infinite real numbers. Got it?
Yes.
So this is the base point to understand what is an interval. Now, intervals. It is about intervals. See, A is a set. 2, 3, 4, 5. That means number of elements. How many elements are there in A?
4.
4 elements, right?
Yes.
But now see, if we write an interval like this, it contains infinite elements. It contains infinite elements. You know why?
Because it's between 2 and 5, sir.
Yeah, between 2 and 5, of course, including 2 and 5, there lies infinite elements.
Yes.
For example, 2.01, 2.001. Do you know the concept of the saying of 2.01, 02, 03?
No, sir.
I think you call it 2.01.
I mean,
2.001. Is
we
it?
don't use it in decimal, sir. We only use it in time.
How do you read this? How do you read 2.01?
2.01 or 2.01.
Okay. 2.01 is correct and 2.01 is also correct.
Yes, sir.
Both are accepted.
Yes, sir.
Right. Okay. Do you know any reason to say 2.01?
I don't know, sir, but they use it mostly for time and numbers here. Like numbers, like phone numbers and all that, or apartment numbers and all that. They use.
Even for 4 numbers, they use 0.
Yes,
Oh,
yes, sir.
really?
Yes, sir.
For example, here 1.108 is there in India, in Telugu states.
108.
108. Oh, really? It's very interesting. It is
Yeah,
read
by
as
the time I call the ambulance, the guy will be dead, sir.
what's the number of ambulance there?
Ambulance? No, sir. We call,
Emergency service maybe.
I don't know, we just call 911.
Okay, 911. Okay.
911 police.
So it's very clear that it is read as 119, 108. 108 means.
108, yes.
Okay, right. Let's find reasons. Okay. See, there are infinite numbers between 2 and 5, right?
Yes.
Now, let us know the names of intervals. Names of intervals are first closed interval. Yeah, one more thing. We should know about this symbol. This symbol is called belongs to. This is called, this used to belongs to. this is doesn't belong or not belongs to. See, for example, if you take this set, if you take a set, A is equal to 2, 5, right?
Yes.
2 belongs to A. Five belongs to A.
Okay.
That means this set contains 2. This set contains 5.
Yes.
2.01 belongs to A.
Yes.
2.001 belongs to A.
Yes.
And 4.9 belongs to A. 4.99999999999 also belongs to A.
Yes.
Okay. So this set contains infinite numbers, first of all. Start from 2 till 5. This set contains all the real numbers, not integers. This set contains all the real numbers.
Yes.
All the real numbers. In between
2 and 5.
Yeah, this set contains all the real numbers in between 2 and 5, right? Clearly, it contains infinite numbers.
Yes.
It contains infinite numbers. So, this is called open interval. This is called open interval. Open interval. It is open interval, right?
Yes.
Now, if we take 2, 5, the bracket is written like this. Open 2, 5. Open interval 2, 5. It is, sorry, it is closed. It is closed interval. It is called a closed interval. It is open interval. What is the difference between these two intervals? In this open interval, 2 doesn't belongs to B.
Oh, the 2 and 5 are excluded and the other numbers are included.
5 doesn't belongs to B. But 2.01 belongs to B. 2.00000000001 belongs to B. 5 doesn't belongs to B. But 4.999999999 doesn't belongs to B. Sorry, belongs to B. Have you noticed the difference between these two intervals?
Yes, sir.
That is closed interval, this is open interval. Yeah, at this time, I would like to give an example, universal example. I came to know that Einstein defined this universe as, do you think that this universe is finite or infinite?
Infinite.
Infinite. So, infinite means if we keep going, it contains matter everywhere.
Yes, sir.
There is no end.
No, sir.
But Einstein defines universe as infinite is universe is finite
it's infinite.
Einstein told that universe is finite but has no boundaries. It can't to digest. It can't. It is difficult to understand. It can't be digested. It is finite, but it has no boundaries. That means no endpoint.
Yes, sir. He's just describing it to be a circle.
Yeah. For example, yeah. See, if we take 2.5, can you say what is its endpoint? What is the endpoint of this interval? That means what is the highest number in this interval?
5.
But 5 doesn't contain the set. 5 is not there in this set.
Oh, some 4.9.
Yeah. Can you tell the highest number in this set?
So it could be the last number of 4.
Yeah. I am asking what's the if last number of this interval is 5. 5 is the last number. 2 is the beginning number. It is beginning number, it is ending number.
Yes, sir.
If you take the interval A, what is beginning number? What is the beginning?
2, sir.
What is ending?
5, sir.
So it has beginning and also ending. It has beginning and also ending. Please tell what is the beginning?
2.1.
No, 2.1 is not beginning.
2.01.
2.01 is smaller than it.
Yes, sir.
It contains 2.1. 2.01 is there. Even less than 2.1. Try. Do you think that 2.001 is the beginning?
Yes, sir.
No, because even smaller number is there.
Yes, sir.
That means having 6 knots.
Yes, sir.
So it has no beginning.
There's no beginning and there's no end, sir.
No beginning, no ending. This interval has, yeah, this is having no beginning, having no ending. Neither beginning nor ending. These type of concepts are useful to understand the existence of universe. Many say even the universe has no beginning, no ending.
Even the energy has no beginning, no ending.
That's why it is an example for having no beginning, having no ending. Yeah, see, we need to think broadly to understand these concepts. Some say that there is no possibility for having no beginning and having no ending. But it is an example, live example, right? So it is called closed interval. It is called open interval. It is called open interval. There are some intervals, semi-closed.
Oh, the first one will be closed and the second one will be open, sir. 5 and open bracket.
Yeah, including 2, excluding 5. Including 2, excluding 5. It is semi-closed. Of course, it is also semi-closed.
Including
Excluding 2, including 5. This is called left closed.
Open bracket.
Right open.
Oh. Right
left
closed,
right
left
open. What about
next
this?
one is right closed, left open.
Yeah, left open, right closed. You know, ultimately, can you think? Can you say anything about this interval? It is also an interval. Open interval. Minus infinity plus infinity. It is nothing but a real number.
Y equals x.
Yeah, it
Sir.
contains all the real numbers.
So in the graph y equals x,
Y is
will
equal.
that, y is equal to x. Will that work, sir?
Tell again, repeat again.
In the graph y equals x, will it not be negative
In the graph y
infinity?
is equal to x.
Yes, sir.
Okay.
Will it not be negative infinity to positive infinity?
Yes, you are right. You are right. I'm telling. See, it's very interesting to have the discussion on mathematical facts like this. I like very much this type of discussion because that's why Srinivas Ramanujan, the famous quotation of Srinivas Ramanujan is, equation seems to be nothing to me if it has no message from the God. To Srinivas Ramanujan, each equation is a message of God. That means Srinivas Ramanujan felt he was talking to God when he studied equations. It must be experienced, not to explain. How equations are from God, we can't understand, but it should be experienced. Yeah, every equation has a meaning. Galileo once said, God is a mathematician, and God created the universe in the language of mathematics. Galileo's quotation is, God created universe in the language of mathematics. It needs a high level of thinking to understand this quote. For example, all the planets are in the shape of are in spherical shape, and movement of planets are elliptical. So it made Galileo to thought that God is a mathematician. Okay, see, as you said, it is a function y is equal to x. It is a graph of y is equal to x. Okay, I want to make a video on this concept. As you said, y is equal to x as minus infinity to plus infinity.
Yes, sir.
It is plus infinity, it is minus infinity.
Yes, sir.
Same idea, I am using same idea to make a video, a short video or a video like using this eraser.
Yes,
It is eraser.
yes, sir.
There is an interesting story about this eraser.
Apsara, yes, sir.
Yeah, once this eraser erases everything. If a student is doing mathematics or doing homework like this, this eraser jumps. If you drop it, it jumps some like this. So once it used to erase everything, every diagram and every square and every triangle like this, this eraser. Then all that from the colony of triangles, from the colony of circles, from the colony of trapeziums, from the colony of rectangles, from the colony of circles, all went to the king and complained about this eraser.
Eraser, yes.
That it erases everything. It erases everything. If a student to draw a triangle, it jumps from to there and erases. So this eraser erases everything. It was their complaint to the king. Then king called eraser and asked the king asked the eraser, "Are you erasing everything?" Yes, I erase everything, and it is my nature because my name itself is eraser. So I erase everything. Then God punished him. Okay, then erase a straight line.
Oh, it's never ending.
Then eraser started to erase straight line. Okay, the eraser came to an end, but the straight line is not erased completely. Partially erased, not erased completely. So at last, that eraser repented and requested God to forgive it. Then the God forgave it and warned the eraser to erase only the required part of the diagrams. Erase whenever the student requested to erase. That part only erase. From then onwards, the eraser erases the requested part only. This story is told by a Russian mathematician. It's very, very interesting book. The title of that book is Play with Geometry. I recommend you to read that book. You can get it in Amazon also, I think, in net. The title of that book is Play with Geometry. It's very, very, very interesting book. I got that book also. Especially students, kids like very much in the language of that book. Russian authors are very interested to create stories with mathematical concepts. I recall that concept when you gave the example y equal x. Actually, if we try to draw the equation of, the graph of this line, we must draw this. This straight line goes to the space.
Yes.
Yeah, exceeding this part, and it must go to the end of the universe. It also go to the end of the universe.
Yes.
That's why, range of, correctly said. You correctly said range of the function f of x is equal to x. Range of the function f of x is equal to x. As we discussed about the range of this function is negative infinity to positive infinity.
Yes, sir.
That is the range of the function.
Yes.
And at this time, please tell what is the range of the function f of x is equal to x square. If we draw, this is the graph of f of x is equal to x square.
So the domain is gonna be negative infinity to positive infinity.
We are not discussing domain. It's range. Range means it's
Okay.
value, output.
So it will be from 0 to positive?
0 to positive infinity, including 0, because 0 is there.
Yes, sir.
So range of this function is
0
to infinity. To understand what is range and what is domain, I'm telling domain and range. Simple. I am giving you simple word. Domain is input. Range is output. Domain input. Range output. What are the inputs of x square? That means what can we write in the place of x? Or what values on the x-axis can be taken to draw f of x square?
So anything.
Whatever we wish. We can take 10. See how to draw the graph of of y equal x square. Let us try to draw the graph of f of x equal x square. That is y equal x square, right?
Yes.
It is graph. Zero, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Say, if x is equal to 0, x and y. If x is equal to 0, what is y?
0, sir.
0, right? So, if x is equal to 0, y is equal to 0, right? Next, if x is equal to 1, what is y?
1, sir.
1, right? If x is equal to 1, y is equal to 1, right? If x is equal to, what is y?
4, sir.
4. If it is 2, it is 4. 1, 2, 3, 4, right? If x equal 3, what is y?
9, sir.
9. So, okay. Is there any number on axis which cannot be taken? We can take x is equal to 100. Then y is equal to 10,000. Is there any number on x-axis not to be taken?
No, sir.
No. We can take any number. We can take any number. We can take any number. So that means it's domain. What do we say about inputs? Input is everything. Everything is it is an input. That means we can write any number. Of course, we can take x here also. Then y may be something higher than that.
Yes.
So what is domain? Domain is every number. Every number means R. R is a real number.
Yes.
That means every real number can be its domain. The domain contains every real number. That means whatever number we can take as x. That means on x-axis.
Yes.
Domain is input. Domain is input. What is the range?
Output.
Output. Yes, right. Is there -2 in the output?
No, sir.
No. -1 is output contains -1 or not?
Yes, sir.
-1. It is -1. That means do this graph passing through -1. That means
no, sir. We cannot do -1.
Do this graph covers -1?
No, sir.
Okay. This graph covers the values 0 to infinity only.
Yes, sir.
So range of this function is
0 to positive.
0 to infinite, including 0. It's about range. Got clarity about range and domain?
Yes, sir.
Right. See, one interesting function is there. Very interesting function is there. That is about x-axis. It's very interesting function. It is this idea. Discussion on this idea is very helpful to understand a special question in calculus. That means pre-calculus. That is the limits. Okay. See. 1, 2, 3, 4. 1, 2, 3, 4. Right. Let us take a function. F of x is equal to x square minus 4 by x minus 2. Okay. Let us find the value of f of 0. F of 0?
-4 by -2. That's 2.
Yeah. That is equal to. That means if x is equal to, sorry, if x is equal to 0, then y is equal to. Agree?
Yes.
So that is the point. It is that point. Okay. Next. If f of 1.
-3 over -1. That's
-3 over -1. That is equal to 3 only, right? So f of 1 is equal to 3. Yes?
Yes.
Right? Next. What is f of 1.9? 1.9 whole square is 3.61. Minus 4 by 1.9 minus 2. That is 0.39 by negative 1.1, negative 0.1. That means 3.9. Okay. So it can be located as x is 1.9. It is 1, it is 2. It 1.9 is like this. Okay. X is 1.1. That its value is nearly 2, nearly 4, but not 4. Can you say what is f of 2?
Sir, no, sir. Not.
No,
It's
because it is indeterminate form.
independent.
That means 2 is not 2 can't be in its input.
Yes, sir.
We should not write 2 x is equal to,
Yes, sir.
because if you write x is equal to, it gets indeterminate form.
Independent form.
That means if you try to draw graph, previously he told about the graph y equal x.
Yes.
The graph like this, it is the graph of y equal x.
Yes, sir.
But if you try to draw graph like this, it is like this. You know, f of 2.1 is also possible. Tell f of 2.1. 2.1 whole square, 4.41 minus 4 by 2.1 minus 2. Total it is 4.1. For 3.9, its value is 3.9. Sorry, for 1.9, its value is 3.9. For